Thank you. Hi, everyone. So quickly before I start, because we usually have a diverse audience, I know some people were here before, but a lot of new people came. Who would be confident enough, quick raise of hands, to explain blockchain to someone else? Okay, maybe a third, not even. A fourth. Who would be confident enough to explain the concept of a smart contract to someone else? Okay, same amount of people. Decentralized Autonomous Organization? Okay, so bear with me, the few people who already know the basics. I would like to give the chance to the majority of the audience to catch up with the basics before we deep dive into the subject matter. So why can we disrupt organizations with blockchain? In order to understand this, we need to understand the history of the internet. So if we look back, the first generation internet, early 90s, revolutionized information, and this is why we called it the information data highway. That was disruptive. Nobody would call it this way today. It doesn't make sense. It's become normal. About 10 years later, we had the so-called Web 2. And what the Web 2 did, it was like the internet became more mature, more programmable, and all of a sudden we had, on the one hand, social media platforms, and on the other hand, a peer-to-peer economy and the sharing economy, where the consumer and the producer came closer to each other, of information, of opinion, of goods and services. So we have. It brought us this peer-to-peer economy, but with this huge man in the middle, this platform in the middle, who started to control all the data, has control over all the data, and dictates the rules of the transactions of that platform. So instead of the internet becoming more decentralized, it became more centralized. And if we think of blockchain in the context of the internet, it is the driving technology behind the decentralized web, or also called, some call it the Web 3. Blockchain allows real peer-to-peer transactions without the middleman, and it all started with Bitcoin, money without banks. So sending two people who don't know and do not trust each other, sending money from and to each other without a trusted third party in the middle. Why is that possible? Or why wasn't it possible before? Because we first had the computer, and then we had the internet. So since the 90s, we started with the internet, with the TCP/IP protocol, or even before, we started connecting computers more and more, first the big ones and the small ones, then the mobile phones, and now we've reached IoT, Internet of Things. And even though our world is more and more connected, data is still stored centrally over this client-server protocol, where one computer stores the data and the other computer asks or reads or writes the data. So data storage is local, either on the computer, the device, end device, or the removable device, and also in the cloud. In the cloud, it's remote, but it's still stored locally. And this brings three big problems or questions. The question of data security, the question of who owns my data and who has the rights to my data, and who can I trust the people who verify the transactions based on that data. So it all boils down to one question of trust. And this is why The Economist now 2 years ago called the blockchain the trust machine, because what blockchain does, it's a protocol that decentralizes trust. So we're moving away from a system of today where data is stored locally on a server, data monarchy, to data democracies kind of setup. And so today, when I send you money and I don't know you, I don't trust you, we would need a bank to verify that I am me, and I have enough funds when I send you that money, so it's not a blank check. And I want to know that you actually received the money, so we need that bank in the middle. With Bitcoin, for example, or blockchain, the peer-to-peer network, copies of the same transaction data of who owned what and when. Same copy of that transaction data is stored on the peer-to-peer network, and instead of a central party verifying transactions, instead of one single bank server verifying transactions, the transactions are verified peer-to-peer in a democratic way by consensus. And it's all done automatically. The computers in the network do that automatically. It's not people behind it, it's machine consensus. So this is highly disruptive. And this machine consensus allows us to have peer-to-peer transactions without the middleman. And the heart of this machine consensus is the smart contract. So the smart contract is not really a legal contract yet. It's not very smart. It's just a piece of code running on top of a blockchain that codifies the rules of a transaction. And when the rules of the transaction are met, the transaction is automatically executed. And that is highly disruptive because this reduces transaction costs of compliance and enforcement, because compliance and enforcement happens on the fly. So if you think of the chess game or a football game, you always have rules of a game. You have a chessboard manager or a Schiedsrichter, a referee in football, soccer, who makes sure that the players to a game can only make moves according to the predefined rules. And this is the function of a smart contract. So instead of, or as opposed to traditional contracts that are printed on paper and signed by hand, a smart contract, and this is not a smart contract, but it's a piece of code that is signed with my private key, which of course doesn't look like this, but it looks like this. It's based on cryptography. There is some. Right. So smart contracts are not a good idea. This thing here is a very primitive form of a smart contract. The rules of the transactions are auto-embedded into the machine, and you need, if you press a certain number and if you put enough money into the machine, you will get the product, and maybe also some return money if you put too much money. If you don't put enough money, you don't get the product. If you put enough money but there is no product, you get your money back. That's a smart contract. So what smart contracts do, they disintermediate in a very radical way and allow us to have these peer-to-peer transactions. We can have simple decentralized applications, and we heard some, for the ones who were listened to the talk before, we had some interesting examples of what we can do with smart contracts. Basically, we can use smart contracts for any industry. So it started with Bitcoin, money without banks, sending money from A to B, but you can have apartment sharing without Airbnb and Wimdu, you can have ride sharing without Uber, you can have selling books without Amazon, etc. So you get rid of the platforms through these decentralized applications, and the heart of those dApps are smart contracts. Now, the highest form of a smart contract is a decentralized autonomous organization. A smart contract can be very simple, of defining the rules of for example, sending money from A to B, under which conditions, if the person who sends the money has more, at least as much as money as they want to send. It's like simple if-then clauses. Decentralized autonomous organizations are nothing else than very complex smart contracts that define the bylaws of an organization, for profit or not profit, into the smart contracts. So what you can get rid of bureaucracy and management overheads through smart contracts. There is another term, the decentralized virtual borderless nation, which basically is just a concept for a political decentralized autonomous organization, but it's the same concept of a smart contract on a blockchain. So what kind of DAOs have we had so far? And if we look at the history of blockchain, which is not very long, but we can say that Bitcoin really is the first decentralized autonomous organizations. It's not only money without banks, but it's also money without bank managers. There is no central Bitcoin authority. So Bitcoin was, the white paper was written by one person or a group of people, we don't know who it was put online 9 years ago, was deployed eventually by a group of after being programmed in an open source way, eventually it was deployed after a few months by a disparate group of programmers worldwide. They deployed it, they mined the first block, and this is when Bitcoin started. So there is no central Bitcoin authorities. Now we have stakeholders in the Bitcoin network. We have the miners, and we have the exchanges, and we have the wallet providers, and we have the users, etc. But there is no central authority. There is not one person or one entity who can turn off Bitcoin. You would need a power outage in the whole world to turn off Bitcoin, right? Or you would need to turn off all the thousands of computers that are part of the peer-to-peer Bitcoin network to shut down Bitcoin. And that's radical. And so what else? What other examples have we had so far? This is really the longest-lasting examples that we had. Last year, I don't know who heard about the DAO that attracted like 180. It was a decentralized autonomous organization on the Ethereum network. The purpose of the DAO, it had a very generic name, was to be an investment fund for Ethereum-based projects, but completely decentralized. The DAO token holders could vote proportionally to the tokens they had upon the projects they wanted to invest in. Now, that project had a few problems, let's say, and stopped, but we've had before and after other DAOs popping up. Another good example for a decentralized autonomous organization is Ethereum. It's also a blockchain that has existed for a few years. Even though I have to stress that Ethereum has a foundation and is, in a way, maybe more centralized than Bitcoin. There is no central party that could take it down, but it has a very strong leadership that can influence opinion. So what else? Then we have BitNation, which is a startup that aims to provide a kind of WordPress for decentralized DAOs, or decentralized virtual borderless nations. They're working on making a platform where you can easily create and deploy your own DAO or decentralized nation. We'll skip this. So maybe it's very important to understand that this technology is very early on in its development. It's kind of like 1990 when it comes to the internet. It's more or less 1960 when it comes to hardware. Because the blockchain, especially the Ethereum blockchain, you could say that it's like a decentralized world computer. It's a distributed network of computers. It's a peer-to-peer network. That peer-to-peer network of computers is the distributed world computer. The protocol could be seen as like the operating system, where you can now run decentralized applications or smart contracts on top of it. So we're reinventing not only the internet, but also the computer. And blockchain is only one of many protocols in that sense. Okay, so now let's look at disrupting organizations, and we've heard that in the previous talk. Let's go a bit into more detail. So if we look at organizations we know today, whether political or economical, they're very much organized in this hierarchical, top-down way, and executed also in this way. I don't know what this is. I think I need some tech help. Okay, I have to improvise now. So organizations have been traditionally organized in a top-down way. Blockchain allows us to disrupt or get rid of a lot of bureaucracy. Smart contracts and the protocols that are machine consensus that is auto-enforceable can now define the rules of an organization into auto-enforceable code. And this way, we can't get rid of all managers, but we can get rid of a lot of bureaucracy, whether in private organizations or in public organizations. And even though this technology is in the very early stages, it has the potential to really disrupt the way we organize society. If you look at Bitcoin, it has a market capitalization of more than a lot of small nations out there, and it's completely run decentrally. Okay, I'm waiting for, so I have to improvise. So on one hand, if we look like, on the political side, let's look what we had before. We had, like for example, we had the kings ruling a dictatorship is very top-down. And when we started to have democracy, the idea was to allow people to participate in the consensus process. The problem with big societies is that not everyone, it's inefficient for everyone to take part in every decision-making process. And this is why the forms of democracy that we have nowadays are representative democracy. These institutionalized representative democracies are in a way very hierarchical. We as citizens, we can vote every 3 years. Or every 4 years, sometimes every 5 years. But in between, we have very little power over what those representatives do. We cannot revoke that power. We have very limited means in most cases. Now, government entities are trusted third parties in a way. And we have seen over the last decades new concepts as liquid democracy, for example, pop up, or sociocracy, etc. The problem with those concepts, even though they're maybe more practical, the transaction costs in the analog or semi-digital world are too high. And with blockchain, with machine consensus, for the first time, we're in a situation where we could make concepts like liquid democracy on one hand, or holacracy on the other hand, when it comes to organizations, happen in a much more efficient way. Yes. So I don't have my slides. I guess, any questions so far? Usually my slides are like kind of my, yes.
Okay, I think it's a good time to go for the Q&A. So I'm sure there are a couple of questions. I can see two. Okay, I'll start with you.
Hi. So very interesting talk.
Yes.
My question is about finding the smart contracts, because
yes.
in my opinion the problem is often finding just the right way to specify the contract
yes.
in order to have like the correct incentives, and there are many different things that can go wrong or that you might not think when designing such a contract.
Exactly.
Can you comment
Thank you for
a bit
the
on
question.
that?
Yeah, these were actually my last slides. I completely forgot. So thanks for the question. So smart contracts or machine consensus is very efficient when we have, in the cases of the known knowns and known unknowns. When we can exactly predict what will happen, it's easy to put that into code and to reduce transaction costs. Smart contracts or blockchains are really lousy when it comes to dealing with unknown unknowns. Because we cannot enforce situations as those unknown unknowns. And we have two examples. For example, in the Bitcoin community for 2 years now, or maybe before. Let's go. So when Satoshi initially designed or defined in his white paper the Bitcoin blockchain, he assumed that you would have individual miners, individual computers running the code on their individual computers. And for the first few years, everybody was running, people who were participating in the Bitcoin blockchain, they could run it on their home computer, right? You needed a powerful home computer, but you could do that. Eventually, the difficulty rose, and you needed even more powerful computers. And what Satoshi did not predict when designing the code was that miners would start to collaborate. So collaborative game theory was not the basis of his math that he did. He used simple game theory. And so what we're seeing now in the Bitcoin community is that miners have colluded to mining pools, and now I would say around 3 to 4 mining pools are currently dominating around half of the Bitcoin network, and most of them are in China. So it's still much more decentralized than a centralized bank, but it's not as decentralized as Satoshi originally envisioned. Another example in the Bitcoin blockchain for what you just said is that when conditions change, for example, there is the block size debate. For 2 years, we've had the block size debate going on in Bitcoin, and the community is or has been on the brink of secession several times. Very divided over how to solve this problem of Bitcoin scalability. So now this is very technical, but what I'm trying to say is that auto-enforceable code is very efficient as long as everybody agrees that this is the way to do it. And the moment that you need to upgrade the code because conditions have changed, we still need some kind of governance. And we don't have those governance structures. So this is something that we still need to work on. Any other question?
If we can have the mic, thank you. There is a question here.
On the left. Hi, on the left here. My question is, if you look ahead for the next 5 years on what kind of organizations will turn into DAOs, I was thinking that maybe consultancies might be, or like a consultancy network could be a DAO.
Anything could really be a DAO. Anything, really. I think the things that will be DAOs in the future, it would make sense to start with less time or money critical things, like the DAO last year. The people who created the code for the DAO, that decentralized investment fund, really didn't envision that $180 million would be invested into that, right? They didn't put a cap on it. So I think because that technology is still in the early stages, it's better, since we can use it for any kind of use case, let's start with the non-essential or non-critical things, because it's still very experimental technology. Blockchain is, I would say, not only a technological revolution, but first and foremost a socio-economic revolution. Blockchain is a tool to bring us into a more decentralized world, but we need the software for this decentralized world in our brains and how we interact as people. And I would doubt that we already have that, and we could see that with the DAO, now with Ethereum, now with Bitcoin. You can see that even though we all long for a more decentralized world, we have been socialized in very top-down structures in a way. So there is a gap between where we want to be and where we can be as a society, because we don't have the soft tools yet.
Okay, I can see another question at the back. I will come to you, and then one more here. And I think after that I will have to close the question and answers, because then we are running out of time. But 2 questions. I will take yours. Please introduce yourself and then pose your question.
Yeah, hello, my name is Lawrence, and you were talking about that blockchain is very decentralized, and since we're witnessing now some sort of a centralization with the big players like Google and Facebook, do you think in the long run this might have an effect on the internet, that it's going to be decentralized again? Even in cultural terms, or
yes,
is blockchain? I
mean, this is the claim of the blockchain, or the claim of Bitcoin was money without banks, countries without politicians, and companies without managers. And also disrupt the disruptors. And the other claim is, let's re-decentralize the internet. So the original vision of the internet was to be a decentralized world where everybody could put information online. But in the Web 2, it became very centralized with those platforms, partly because our data structures this is what I try to explain, are very centralized. Because we first had the computer, and then we had the internet. So when we started to have the internet, we took over those centralized data structures. And what we're doing now with blockchain and IPFS and all these other technologies of the decentralized web, we're redesigning data structures given the fact that we are already living in the connected world. And so by that, we hope, and that is the aim of the Web3, to live in a more decentralized world in the future. But there are many, many stumbling blocks to that. One is the problem of the unknown unknowns and the limitations of smart contracts and what they can auto-enforce. So we need distributed kind of dispute resolution systems. What do we do when those unknown unknowns occur? We need dispute resolution. We need some kind of governance mechanisms that we don't have yet. That's on one hand. And yeah. And on the other hand, what was your question again? Can you reformulate your question again?
I think if I understood it correctly, because his question was more about like on the one hand, the internet becoming more centralized, yes. And then what are the potential?
It is becoming more decentralized. One of the problems that we're also seeing now is that even though we want to create a more decentralized world, blockchains, state-of-the-art blockchains, are based on plutocratic governance rules. The more tokens you have, the more power you have, or the more hashing power you have, the more mining power you have, the more decision power you have in the network. And so what we're doing, state-of-the-art blockchains are actually making the discrepancies of the poor and the rich bigger on-chain. So as long as we don't move to more democratic voting structures and decision structures off-chain or on-chain, I think we might not, decentralization might be more theory than reality. So we have to be careful about that.
Okay. We have one last question, if that's possible.
Hi. With you saying that like we're pretty much in the 60s of like the third revolution of internet, whatever internet is, what's your feeling towards blockchain as a concept and as a technology or as a basis for smart contracts and technologies that can be built on that concept? Isn't it something that might stay something that's like an elite thing? I mean, right now it's quite tough to understand the concept, and there are only a few people who could actually deal with the technology itself. So what is your feeling towards that? How can blockchain evolve and the technology and the way we deal with it evolve in a way that actually enough people can deal with that and set up rules and in the end finally maybe even code smart contracts themselves?
I think it really boils down to the matter of time. So basically when it comes on the application level, we're like early 90s, where email was the first application of the internet. And for those who were old enough to remember, I used email when I was 20 the first time. So for me, that was the internet. That was even before the World Wide Web. I didn't envision Facebook or Twitter or anything. And I think nobody did in that way. I was one of the early adopters, so I think what we need, Bitcoin now really is the first killer application of blockchain, and we haven't had another killer application. So I think in terms of usability and scalability, in the next 2 or 3 years, we might have the first killer application where my grandmother can also use it, and once we have that, I think blockchain will really take off on one hand, and blockchain, a lot of use cases of blockchain are built on network effects. When it comes to accounting, when it comes to supply chain, Internet of Things, etc. So we're not there yet. So I think, yeah, we need another 5 to 10 years. For those use cases where we need extreme network effects, we need another 5 to 10 years. And hopefully the first killer application the next 3 years. Pi mal Daumen. Yeah. Okay. Good.
Okay, thank you very much, Shermin Voshmgir.
Okay, and just thank you. we have the last slide up and running. So blockchain is a deep topic. You can find a lot of information on our website or follow us on social media.